You are moving faster than most jet engines have ever flown. Not in a metaphorical way, in a measurable physical way. The ground beneath you is rotating eastward at roughly 1,000 miles per hour if you're near the equator. At the same time, Earth is sweeping around the Sun at tens of thousands of miles per hour. And the Sun, dragging every planet, asteroid, and grain of dust with it, is circling the Milky Way at a speed that makes even that orbit feel slow. And yet, your hands don't buzz. Your vision doesn't smear. The air in the room doesn't slam into your face like a constant storm. A glass of water can sit perfectly still, as if the universe were motionless. That calm is not evidence that you're still. It's evidence that motion can be so uniform it becomes invisible. If you want to understand why the cosmos seems to spin while your body feels fixed, you have to start with an idea so quiet it's easy to overlook. Your senses don't detect speed. They detect change. Your inner ear is not a speedometer. It's an alarm system. It reacts when velocity shifts, when you accelerate, decelerate, turn sharply, or stumble. The moment a car lurches forward, you feel it. The moment an elevator begins to drop or rise, your stomach notices. But once the motion becomes steady, your body recalibrates. It stops reporting what it cannot use to survive. That's why you can drink from a cup on a smooth train, why you can walk down an airplane aisle while the aircraft is racing through the sky. You only feel motion when motion stops being uniform, when turbulence arrives, when the brakes engage, when the path bends. Earth's rotation is old, smooth, and consistent on the scale your nervous system cares about. Not perfect, nothing is, but steady enough that your biology treats it as background. You don't feel the planet's spin for the same reason you don't feel the sun's gravity pulling on every atom in your body. It is constant, and your body is built to ignore constants. In physics, this is not a trick of perception. It's a principle. If everything around you shares the same motion, then within that shared frame, moving and not moving become the same experience. What matters is relative motion, differences that can push, strain, or rearrange you. A sealed spacecraft orbiting Earth is a clean demonstration. The station and everything inside it are moving rapidly, but they're moving together. With no floor pushing upward, no seat forcing a body into a curve, the sensation of speed disappears. Motion becomes a kind of silence. Even on Earth, you can watch this silence crack open if you choose the right experiment. Suspend a heavy pendulum so it can swing freely, and let it run for hours. The pendulum keeps its plane of swing while the Earth slowly turns beneath it. No engines, no motors. Just a quiet mismatch between the motion of the pendulum and the motion of the ground. Over time, a pattern emerges, not because the pendulum is changing what it's doing, but because Earth is. The deeper you look, the more you find that rotation is not an odd habit of planets. It is a theme. Clouds of gas that collapse into stars rarely fall perfectly straight inward. The universe is messy in a particular way. A slight asymmetry becomes a permanent preference. As the cloud contracts, any tiny initial swirl becomes amplified. The same amount of spin gets packed into a smaller space, so the rotation speeds up. The result is a newborn star, surrounded by a disk. A flattened, rotating structure from which planets can form. Your day is a relic of that ancient swirl. And once rotation exists, it does not vanish easily. Space provides almost no friction. A spinning world can keep turning for billions of years unless something drains its angular momentum away. On Earth, that something is largely the moon, tugging on oceans and rock, pulling energy out of rotation in microscopic increments. The change is slow enough to be invisible in a lifetime, yet real enough to matter across epochs. So the stillness you feel is not the absence of motion. It is synchronization. You, the air, the oceans, the mountains, the atmosphere, everything nearby is moving in near unison, like a vast mechanism whose parts don't grind because they're turning together. The universe doesn't announce its motion with noise. It announces it with gradients, with differences, with places where the rhythm changes. And that opens a deeper question. If rotation is so widespread, if it echoes from atoms to planets to galaxies, where did the very first twist come from? What started the cosmic tendency to turn? Because once you notice that stillness is just shared motion, the next mystery becomes unavoidable. Not why you can't feel the spin, but why the universe seems unable to stop spinning at all. If you could rewind reality far enough, you would eventually reach a moment where planet and star stop being meaningful words. No oceans, no continents, no sunlight, not even atoms. Just a young universe, hot, dense, and expanding, where everything you recognize is still locked inside a state too energetic for structure to hold. And this is where the question becomes sharp. If nearly everything we see is rotating now, did the universe begin with a spin? Or did rotation emerge later, like ripples forming long after the first splash? The honest answer is unsettling. We don't know for sure. But we do know something equally important. Rotation doesn't need a grand cosmic hand to begin. It only needs imperfection. Imagine a perfectly symmetrical collapse, matter falling inward with absolute balance from every direction. In that idealized scenario, there is no preferred twist, no leftover swirl. Everything rushes inward like a silent, flawless implosion. But the real universe is never that clean. In the actual cosmos, collapse is lopsided by default. There are always tiny asymmetries, a slightly denser patch, a slightly faster stream of gas, a slightly uneven distribution of energy. And once you have even the faintest sideways motion, rotation becomes inevitable. Because angular momentum is stubborn. It doesn't vanish. It transfers. It redistributes. But it refuses to be erased. So the more precise question isn't who set the universe spinning, it's how early could spin appear, and how far could it spread? At the earliest times we can describe with confidence, the universe was filled with fields, fundamental entities that can hold energy, fluctuate, and ripple. Quantum mechanics says those fields were never perfectly still. Even emptiness jitters. Not because something is wrong, but because uncertainty is built into the fabric of nature. Those fluctuations were microscopic at first, tiny variations in energy and density. Then the universe expanded. And expansion is not just stretching distance, it is stretching influence. When space grows rapidly, it can take small fluctuations and inflate them into large-scale patterns, like a small crease in fabric, becoming a visible fold when the cloth is pulled wide. This is how structure begins, not from perfect smoothness, but from faint irregularities that gravity can later amplify. And once irregularities exist, spin becomes easy to generate. Gravity pulls matter inward. Matter falls, collides, shears, and streams around denser regions. Any imbalance in those flows produces rotation, sometimes slight, sometimes violent. Over time, collapsing regions don't just form spheres. They form disks, they form spirals, they form rotating halos of invisible mass, guiding the visible material like a silent scaffolding. That's why rotation isn't a rare feature. It's what gravity tends to produce when reality isn't perfectly symmetrical. But there's another possibility, even stranger. What if rotation isn't only a property of objects? What if rotation is written into space-time itself? Some cosmological ideas allow for a universe with a faint, global twist, so slight that it wouldn't look like a spinning ball, but it could leave subtle fingerprints in the oldest light we can observe. The ancient afterglow of the early universe contains patterns, tiny variations and alignments, that scientists measure with incredible care. Some of those patterns have sparked debate. Are they clues to a deeper cosmic structure? Or are they artifacts of how we observe and process the data? The key point is this: the question is open, and the universe has not given a simple answer. Yet even if the universe as a whole is not rotating, the outcome doesn't change much, because rotation would still emerge everywhere once matter starts to clump. And clumping began early. We've seen galaxies so distant that their light has been traveling for nearly the age of the universe, and even those young systems show organized motion. They're not fully settled, not calm, but they're already structured, already turning, as if the cosmos didn't slowly learn to rotate, but arrived predisposed to it. And then we descend to the smallest scale, where the word spin becomes something else entirely. In quantum physics, particles have a property called spin, but it isn't a tiny ball literally rotating like a planet. It's a built-in form of angular momentum, a label that determines how the particle behaves, how it responds to magnetic fields, how it fits into the rules of matter. It's not rotation in the everyday sense. It's deeper than imagery, but it does something profound. It makes twist part of matter's identity. So even if the cosmos had begun perfectly still, which is unlikely, rotation would still appear as soon as matter began interacting, collapsing, and organizing. The universe doesn't need an external push to begin turning. It only needs the slightest asymmetry, a tiny mismatch, a faint sideways whisper. And from that, across billions of years, rotation becomes the default signature of structure, spanning from swirling galaxies to the turning of a planet under your feet. And that leads to the next question, quietly waiting behind this one. If spin is everywhere, does it merely decorate the universe? Or does it make certain kinds of worlds, certain kinds of life, possible in the first place? Rotation is not just a detail of how worlds move. It is a condition for whether worlds can live. Imagine a planet that does not turn. One side would face its star forever, locked in relentless daylight. The other would never see light at all. Heat would pile up on one hemisphere and vanish from the other. Oceans would boil on one side and freeze solid on the other. Between them would exist a narrow band of chaos, permanent storms, violent winds, unstable chemistry. Not a gentle place for complexity to grow. Rotation changes everything. When a planet spins, energy is shared. Heat moves. Light arrives, then leaves, then returns. Temperatures rise and fall instead of climbing endlessly. Atmospheres circulate instead of collapsing. Water flows instead of stagnating. Day and night are not conveniences. They are stabilizers. On Earth, a single rotation takes about 24 hours. That number is not sacred, but it is meaningful. Long enough to warm the surface, short enough to prevent runaway heating, slow enough to avoid constant hurricane-force winds, fast enough to keep air and oceans in motion. This balance is not accidental. Rotation drives the invisible systems that make a planet habitable. As Earth turns, moving air is deflected, setting up large-scale circulation patterns. Winds curve, storms spin. Ocean currents form long, slow rivers of heat that redistribute energy from equator to pole. Without that turning, the atmosphere would behave very differently. Weather would lose its rhythm. Climate would fracture. And beneath all of that, rotation reaches deeper still. Deep inside Earth, molten metal circulates in the planet's core. That motion, combined with rotation, generates a magnetic field, an invisible shield that deflects charged particles streaming from the sun. Without it, the atmosphere would erode. Water would thin and vanish. Life would be exposed to radiation intense enough to sterilize the surface. Rotation, in other words, protects memory. It preserves air. It preserves water. It preserves the conditions that allow chemistry to repeat itself long enough for biology to emerge. And this isn't just true here. Across the solar system, rotation tells the story of survival and loss. Mars rotates at nearly the same pace as Earth, but its smaller size allowed its core to cool faster. As internal motion slowed, its magnetic field weakened. Over time, the solar wind stripped away much of its atmosphere. Rivers dried. Oceans vanished. A world that once may have been habitable became quiet and cold. Venus rotates extremely slowly, and in the opposite direction of most planets. Its atmosphere became trapped in a runaway greenhouse state. Heat had nowhere to go. Temperatures soared high enough to melt lead. Rotation didn't just shape Venus's climate. Its absence helped destroy it. Even gas giants revealed the rule. Jupiter spins so rapidly that its day lasts less than 10 hours. That speed drives immense jet streams and storms that persist for centuries. Rotation organizes chaos into structure. Bands, vortices, long-lived patterns that wouldn't exist otherwise. Too fast, and worlds become violent. Too slow, and they become unstable. Somewhere in between, balance emerges. Life, as far as we can tell, prefers that middle ground. And rotation doesn't just shape planets. It shapes biology itself. Life evolved under a rotating sky. Circadian rhythms, internal clocks found in nearly every organism, are synchronized to the cycle of light and dark. Cells anticipate sunrise and sunset. Hormones rise and fall with planetary motion. Growth, repair, sleep, and awareness all align with a world that turns. Remove that rhythm, and biology falters. Even in controlled environments, living systems struggle when natural cycles disappear. Time, for life, is not abstract. It is mechanical, written into motion. And rotation carries influence even deeper, down to molecules. The building blocks of life are not symmetrical. Amino acids come in left and right-handed forms, but biology overwhelmingly chooses one orientation. DNA twists in a single direction. Proteins fold with consistent bias. Life is directional. That bias may trace back to cosmic processes. Light interacting with matter in rotating magnetic fields. Subtle asymmetries amplified over time. The universe itself appears to favor certain directions, not violently, but persistently. Rotation doesn't just move matter. It selects. It filters. It allows certain structures to persist while others fade. So when we ask whether spinning makes life possible, the evidence suggests a quiet answer. Not by itself. Not automatically. But without rotation, complexity struggles to hold. Life requires repetition without stagnation. Change without collapse. Stability that still allows novelty. Rotation provides that balance. It turns extremes into cycles. It transforms energy into rhythm. It gives time a structure organisms can follow. And once life appears, it doesn't escape rotation. It inherits it. Every heartbeat is a cycle. Every breath is an oscillation. Every neural signal is a pulse. Life doesn't stand still inside a moving universe. It mirrors the motion. And that raises a deeper possibility, one that begins to blur physics and perception. If rotation shapes planets, climates, chemistry, and biology, what happens when rotation becomes so intense that it no longer just organizes matter, but begins to bend time itself? When rotation grows extreme, it stops behaving like motion and starts behaving like architecture. At everyday speeds, spin is intuitive. A planet turns, a storm curls, a galaxy spirals. But when mass rotates fast enough and concentrates enough energy into that motion, rotation doesn't just move things through space. It reshapes space and time themselves. This idea sounds abstract until you realize it has already been tested. A rotating object does not simply exist inside space-time. According to relativity, it drags space-time along with it. Not metaphorically. Literally. Imagine space-time as something that can flow, like a thick, invisible fluid. When a massive body spins, it stirs that fluid. The faster the spin and the greater the mass, the stronger the stirring. This effect is subtle around Earth, dramatic near neutron stars, and overwhelming near black holes. On our planet, the effect is tiny, but measurable. Sensitive instruments placed in orbit have detected that Earth's rotation slightly twists the surrounding space-time, pulling it around like honey caught on a turning spoon. Time itself is caught in that twist, flowing just a little differently depending on where you are and how fast you move. This means time is not universal. It is local, contextual, dependent on motion. Near a rapidly spinning, massive object, time slows down relative to distant observers, not as a feeling, but as a fact. Clocks tick differently. Signals stretch. Cause and effect bend. Nowhere is this more extreme than near a spinning black hole. A non-rotating black hole is already strange enough, a region where space-time curves so steeply that all paths lead inward. But add rotation, and the geometry becomes exotic. A spinning black hole doesn't just pull space inward, it drags space around itself. Near the event horizon, this dragging becomes so intense that nothing can remain stationary. Even light is forced to orbit briefly, caught in a swirling region where standing still is no longer an option. In that region, called the ergosphere, motion is mandatory. Time itself is swept along. If you could observe from a safe distance, you would see clocks near the black hole ticking slower and slower. Events stretch out. Processes freeze. From the outside, time seems to grind nearly to a halt. From the inside, nothing feels unusual, until the geometry makes escape impossible. Rotation has transformed time from a steady backdrop into something flexible, responsive, shaped by motion. And this isn't limited to cosmic monsters. Even satellites orbiting Earth experience time differently than clocks on the ground. Their speed and altitude change how fast time flows for them. Without constant correction, navigation systems would drift, locations would slide, and precision would collapse. Modern technology works only because we account for the way motion bends time. So rotation doesn't just define days and nights, it defines seconds. The faster you move, the more time slows relative to those left behind. The deeper you fall into a gravitational well, the more future you skip past. Motion and time are inseparable, two expressions of the same underlying structure. This leads to a disturbing realization. If rotation can shape time locally, then the universe's overall motion, its expansion, its distribution of mass, its large-scale structure, also shapes the global flow of time. There may be no single now for the cosmos, only overlapping timelines, each shaped by how matter moves. And once you see that, the idea of time as an independent thing begins to dissolve. Time is no longer a river flowing uniformly everywhere. It becomes a pattern that emerges from motion itself. Spin gives time texture. It creates faster and slower regions. It allows clocks to disagree. It makes the universe asymmetric, not just in space, but in duration. Which brings us to an even deeper question. If motion shapes time, and rotation is conserved, then what ultimately governs the universe's rhythm? What sets the pace of existence itself? Because once time is understood as something that emerges from motion, the question, what is time, quietly transforms into something more unsettling. If everything that spins eventually slows, what happens to time when the universe itself begins to forget how to turn? Every rotation carries a debt, not one that must be paid all at once, but one that is slowly settled across immense spans of time. Planets lose spin, stars shed angular momentum, galaxies transfer motion outward as they collide, merge, and stretch apart. Nothing stops abruptly, but nothing turns forever at the same pace. The universe is not running down like a machine breaking. It is relaxing. On Earth, this process is already underway. The moon raises tides in our oceans, and even in the solid rock beneath our feet. Those tides lag slightly behind Earth's rotation, and that lag acts like a brake. Energy is transferred outward. Earth's spin slows by milliseconds per century. The moon drifts farther away. Days grow longer, so quietly that no human lifetime can feel it. On cosmic scales, the same principle unfolds more dramatically. Galaxies interact. When two spiral galaxies approach one another, their stars rarely collide, but their gravitational fields do. Vast halos of unseen mass overlap, exchange angular momentum, and redistribute motion. The result is often a single, larger galaxy with less overall spin. Spirals soften into ellipses. Ordered rotation becomes randomized motion. The universe trades rotation for dispersion. Stars follow a similar path. As they age, stellar winds carry angular momentum away. Magnetic fields act like invisible brakes. Young stars spin quickly. Older stars slow. Even the most extreme rotators, neutron stars, gradually lose energy, their pulses lengthening, their once razor-sharp timing growing tired. And yet, even here, motion never truly vanishes. It migrates. When massive stars collapse, their spin doesn't disappear. It concentrates. Matter falls inward, rotation speeds up, and a neutron star or black hole is born. For a time, rotation becomes more intense than ever, storing ancient angular momentum in an object no larger than a city. Black holes are the last great vaults of spin. They can rotate at speeds approaching the ultimate limits allowed by physics. Space itself is dragged into their motion. Time slows dramatically near their horizons. For eons, they hold onto that rotation, shaping their surroundings, powering jets that cut across galaxies. But even black holes are not eternal. Over unimaginable timescales, they leak energy. Their spin bleeds away through interactions, radiation, and the subtle quantum processes that allow even darkness to fade. When the last black holes finally evaporate, the universe will be left without its strongest engines of rotation. What remains then is not chaos. It is balance taken to its extreme. Energy evenly spread. No gradients, no preferred directions, no meaningful motion. This is the state physicists call maximum entropy, a condition where nothing happens, not because laws are broken, but because there is nothing left to drive change. In such a universe, rotation still exists mathematically. Angular momentum is conserved. But without structure, without contrast, it loses significance. Spin becomes indistinguishable from stillness. Time, in that state, becomes strange. If nothing changes, what does it mean for time to pass? Clocks require processes. Processes require differences. Without motion that creates contrast, time loses its markers. Seconds, days, and years stop being meaningful units. Duration persists, but experience does not. The universe doesn't end in an explosion. It ends in forgetting. Forgetting how to distinguish motion from rest. Forgetting how to measure before and after. Forgetting how to turn change into events. And yet, even here, something remains extraordinary. Because long before that future arrives, long before the last stars fade and the last rotations thin into silence, something has already happened that may never happen again. The universe became aware of motion. On at least one small world, in one quiet corner of a turning galaxy, matter arranged itself into systems that could notice patterns, that could measure cycles, that could remember rotation, even as it slowly unwinds. Life does not stop the universe from cooling, but it witnesses the process. And consciousness, whatever its deeper nature, may be the universe's brief way of holding on to rhythm while rhythm still exists. A localized resistance to forgetting. A moment where motion becomes memory. Because memory is just structured change preserved over time. And you are made of it. Your atoms carry angular momentum inherited from the earliest moments of the cosmos. Your planet turns beneath you. Your star orbits its galactic center. Your thoughts arise from electrical signals, charged particles moving in loops and waves inside your brain. You are not outside the universe's motion. You are a temporary pattern within it. So when the universe one day grows quiet, when rotation thins and time loses texture, the fact that it was once noticed may matter more than the fact that it fades. For now, motion still exists, time still flows, and awareness still flickers inside a spinning cosmos that has not yet forgotten how to turn. Then let us end where motion becomes meaning. Not with an answer, but with a quiet understanding. The universe does not rush. It turns, slowly, patiently, without intention or urgency. From the first fraction of a second to the farthest future, it has never stopped moving, only changing the way motion is expressed. Spin becoming orbit, orbit becoming drift, becoming stillness so gradual it feels eternal. And in the middle of that long unwinding, there is you. You are not an interruption in the universe's story. You are one of its patterns. Your sense of time, past, present, future, is built from motion remembered. Neurons firing, waves oscillating, atoms vibrating. Every thought you've ever had required something to move, to change, to rotate from one state into another. Consciousness itself is not separate from physics. It is physics, arranged delicately enough to notice itself. When you remember a moment, you are conserving motion. When you imagine the future, you are extending it. When you rest, you are still spinning, just more quietly. Even sleep is not stillness. It is rhythm slowed, not stopped. One day, far beyond anything we can experience, the universe may grow calm enough that nothing distinguishes before from after. Motion evenly spread. Spin without contrast. Time without events. A cosmos that remembers nothing because there is nothing left to remember with. But that future does not erase this moment. Because right now, the universe is awake somewhere. Right now, it is capable of wondering why it spins. Right now, it can feel still while moving impossibly fast. Right now, it can ask questions about its own beginning and imagine its own ending. That capacity is rare, perhaps fleeting, possibly unique, and you are participating in it simply by being here. So, when you feel still tonight, remember this. Stillness is not the absence of motion. It is motion in agreement. You are moving with the earth, with the sun, with the galaxy, with the faint ancient rotation that began everything. Nothing is pulling you through time. You are riding its curve. And as long as you can notice that, as long as awareness exists anywhere in the cosmos, the universe has not forgotten how to turn. It is still remembering itself through you.